So we have to find the limit for this given expression, right? Beta is given to be limit of this thing, right? So now see this denominator here, this is x into sine square x, that is straight away I can write as x, because sine square x upon x square times x square. This sine square x upon x square is 1 simply. So this denominator I can write as x cube straight away, right? So beta is limit x tends to 0, e to the power x cube minus 1 minus x cube whole to the power 1 by 3 plus 1 minus x square to the power 1 by 2 minus 1 times sine x, and then the whole thing upon x cube I can write it as. Okay, so this is equal to, I can write e to the power x cube. Okay, I will subtract a 1 here and then add 1 here. Okay, so I'm adding and subtracting 1 here. So e to the power x cube minus 1 plus 1, then minus the remaining thing was 1 minus x cube whole to the power 1 by 3, 1 minus x square to the power 1 by 2 minus 1, and the whole thing upon x cube, right? Now see, this is limit x goes to 0, right? Now see, I'll split this whole thing into 3 terms, okay? And if all the 3 terms have finite limits of their own, then that is allowed, okay? So I will split this thing here into 3 terms and check if the 3 terms have their own finite limits. This plus, now the second thing is going to be 1 minus x cube whole to the power 1 by 3 whole upon x cube, plus the last thing is going to be 1 minus x square, this thing whole to the power 1 by 2 minus 1, and times sin x upon x cube, right? Now if these 3 terms have their own finite limits, then this is, now here this sin x and this is x square into x, so this sin x upon x I can write as 1 simply, right? So I can remove this and say that is 1. So I'm left with only an x square in the denominator here, right? So let's see the 3 terms one by one. Okay, the first one here, you see for x tending to 0, the limit is x tending to 0. Numerator is going to 0, denominator is going to 0. I can use the L'Hospital rule or the L'Hopital's rule, right? Differentiate the numerator, that is going to be 3x square times e to the power x cube upon 3x square. This gets cancelled. For x tending to 0, this is going to be 1, right? X tending to 0, this is going to be 1. So the limit of this thing is 1. Okay. Now see the limit of the second one. This is again for x is equal to 0. This is again 0 upon 0 form. I can use the L'Hospital's rule or the L'Hopital's rule. Okay. Now let's see the second term. Okay. I differentiate the denominator and the numerator both. Okay. So I will get minus 1 by 3 times 1 minus x cube times minus 3x square, okay, upon 3x square, right? This minus 3x square gets cancelled with this. For x tending to 0, this will be 1, okay, and there is a minus sign left from here, so this whole thing will become 1 by 3 plus 1 by 3. So the second term here is 1 by 3, okay, so 1 plus 1 by 3 plus, now let's see what is the last term is. Okay, so this one here again it is 0 upon 0 form. For x tending to 0, x tending to 0, again that is 0 upon 0 form. Okay, 1 minus 1 is 0 upon 0, right? So again I'll use the same L'Hospital's rule. So that is going to be half 1 minus x square to the power minus 1 by 2 into minus 2x here, okay, upon 2x in the denominator. Okay, so if I cancel this 2x with this 2x and I put the limit x tends to 0, so this thing will become 1 to the power minus half, that is 1 only. This minus sign was left, so this is minus 1 by 2. Okay, so finally the 3 terms have their own finite limit, so it was okay to split them like that. Okay, otherwise if any of the 3 terms was not having a finite limit, then it's not okay to split it into 3 terms like that. Okay, so finally my beta is going to be 1 plus 1 by 3 minus 1 by 2. That is 1 by 2 plus 1 by 3, that is 5 by 6. So the value of beta I am getting as 5 by 6. So that means 6 beta is equal to 5. Okay. And the question says, what is the value of 6 beta? That is 5. Hence, that's the answer. Okay. Thank you.